Okay, good morning. As you can hear, I'm not in good shape today, but it's not COVID. I have no fever, my sense of smell is untouched, and my antigen test was negative. So I am another one, Fiala, and I am here to introduce the core facility for NMR Spectroscopy, which goes by the full title, Josef Dadok National NMR Center. Okay, so first I will answer the obvious question, who is Josef Dadok? Then I will give you some things to take into account if you want to use NMR. Then I will introduce what equipment we have, what people we have, how you can access our facility, get training. I will mention user survey that was recently done. And I will remind you that if you use our services, you have to give acknowledgement to our facility. And I will show you how smart and hardworking users we have by showing a few recent high-profile publications. So Josef Dadok is a Czech engineer who started building NMR spectrometers in the Academy of Sciences in the 1950s and 1960s. And after that, Tesla company was making the spectrometers according to his design. So he is a person who has the most credit for Brno being so strong in NMR spectroscopy. Actually, both Vladimir Sklenář and I were starting with NMR in the department he was founded, though years after he had left. This spring we had an internet conference of Czech NMR community, and Josef greeted us from his retirement home in Bloomington, Indiana. He learned how to use MS Teams for that occasion. And after, in a following phone conversation, we agreed that now we had practice, and in 5 years, when he is 100, everything will be perfect. Okay. So if you want to use in NMR spectroscopy, you have to keep in mind some specific. So what is NMR spectroscopy good for? A good point is that the information you can get is very detailed, because you get signals specific to every atom of the molecule. So, for example, not only you know that the molecule is interacting, but you can find out which atoms or which part of the molecule is interacting. It can be used, or samples can be both in liquid or solid state, though our facility is better equipped for the liquid. We do only simple solid state application. And besides the structure, NMR can study also the dynamics and interactions of the molecules. And what is also important, it's very gentle to the sample, because the energy levels of atomic or magnetic moments of atomic nuclei differ very slightly. So actually, when you measure NMR spectra, you do not harm your sample in any way. You can do it even in on living organisms. But the fact that you use very little energy has also some consequences, and this is that NMR spectroscopy has low sensitivity compared to other modern analytical techniques. Consequently, the measurements can be long. In the cases of proteins and nucleic acids, you routinely need isotope enrichment. Data interpretation can be laborious, depending how difficult question you have, of course. For example, if you just need to know whether the protein is folded or not, it is simple. But if you want a complete 3D structure, it's months of full-time work. And of course, the NMR equipment is very expensive. So let's look what expensive equipment we have. So we have 6 NMR spectrometers in the field 500 to 950 megahertz. Of course, megahertz is not a unit of magnetic field, but this means that the proton or hydrogen 1 resonates at these frequencies. To alleviate a little bit the disadvantage of low sensitivity, for 5 out of these 6 spectrometers, we have the cryoprobe. A cryoprobe does not mean that it would freeze your sample. You can choose your temperature in sample temperature in a reasonable range, let's say from -40 to plus 120 degrees. But the circuitry of the probe works at low temperature to simply decrease the noise and to get better sensitivity. The equipment is not the very best in the world, but it's close enough. So probably if our equipment is not good enough for your task, that chances are no one else's will be either. This applies mainly to the biomolecular NMR, for which we are equipped. We have the best equipment. It could be different, let's say, for the solid state. So what you need to use our core facility? Of course, you need the sample. As I said, the sample can be either liquid or solid, and you need a lot of it. You need generally milligrams of the compound you want to study. Of course, the range is quite large, depending on the size of the molecule, depending on how difficult questions you are asking. And for liquids, you dissolve it in about ½ milliliter of suitable solvent. You can get along with less, but of course at the expense of sensitivity. Then the sample should be soluble in some reasonable solvent. For NMR, for technical reasons, we use deuterated solvent. Of course, if you are an occasional user, you don't have to buy it. We do have, but if you use it routinely, you better go to get your one. Then the sample has to be stable over the measurement, over the time of measurement. The shortest possible measurement is about 10 minutes. So it does not mean that it's the measurement itself takes 10 minutes, but there is a preparation period, shimming, tuning, calibrations, and so on. And I already mentioned the temperature. It also depends on which probe you are working. And second, of course, you need to know what you are trying to find out. Sometimes I get questions, can you measure a spectrum for me? The chances are most of the time we can, but this is usually not what the user means, because the spectrum is just a plot of intensities versus frequencies. Who cares? You probably want to know something about your sample. So the best way, or frequently, it is that you go across a publication and you see, wow, this would help me as well. I want it. And so take the PDF, send it to us, and we read it and tell you right away whether we can do it or not. I don't think I have to comment about these. We generally can measure all types of common spectra. Besides high field NMR spectrometers, we have on our webpage listed also 2 pieces of equipment different from NMR or to work with NMR. One is the bioreactor for NMR studies in living mammalian cells. This was built by Trantirex Group. and as a part of a project, and there was a condition of the grant that it has to be made accessible to public afterwards. So it is made publicly accessible through our core facility, though it is still in the hands of Tranquirex people. So if you would want to use it, you would have to talk to Tranquirex group. Another piece of equipment we got in a similar way is a simple EPR spectrometer. The spectrometer was originally bought by Steffels Group, but after the project finished, it was transferred to our core facility. It is in the listed in the booking system, so you can book it. It's a simple instrument, quite easy to operate, but if you need instructions or training, Karel Kubicek is the best person to talk to. So what's new in our lab? So all electronics of all our spectrometers was upgraded to the latest generation, which Bruker calls NEO. Of course, from the electric point of view, everything is happening faster and with greater precision. But on the spectra, the difference is not that big that you would immediately notice. I did observe greater dynamic range or less T1 noise in 2D spectra, but the most important point is that the units are new, and they should serve us well throughout the end of the decade. Then we got so-called BSNL units. It's a unit for nitrogen liquefaction. This is this hose and this cap over here. You certainly know that NMR magnet has to be cooled with cryoliquids, and these cryoliquids have to be refilled from time to time. In the case of nitrogen, it is in 2 or 3 weeks, and this unit extends this period to 6 months or more. That means we do not have to interrupt the experiments so often for the maintenance. Then we have 5 new probes. 4 of them are cryoprobes. The major addition that nitrogen fluorine 19 will be possible on all the instruments now, because it has become fluorine has become favorite probe into the modified biological molecules because there is no natural background. Then we have carbon optimized probe for 850 and proton optimized probe for 700 megahertz spectrometer. The old one are the other way around, so now we have more options. New probe has a greater temperature range, all of them from -40 to 150. And we are also getting diffusion probe for the 700 megahertz spectrometer, which should allow you to study or measure the molecular weight with sufficient precision, because the standard probe can do it, but usually the measurement is not precise enough to tell you whether you have a dimer or a monomer in your sample. It can just distinguish small molecules and big molecules. So this diffusion probe should do it. It has not been installed yet, so I cannot tell you the experience yet, but it should work like that. Okay, then we have people. It looks quite a lot of people, but actually, except for Jaromír Toušek, all people work only part-time in the facilities, so total workload is something like 3.2. This year we made the first step to improve the gender balance of our facility by hiring Katka Bouskova. So this is a small step for SATEC, but a great leap for our facility. If you compare her field, her specialization is close to Otahumpas. And the reason is, of course, that as Katka's sons will grow and become more independent, her workload will increase, while as Ota's grandchildren grow and become more independent, his workload will gradually decrease. A keen observer would notice that there are 6 people listed and only 5 pictures. Petr Padeta is missing. This is an IT guy who takes GDPR very seriously and does not want to make his personal data public. And I also should mention Pavel Kadezávek, who originally was an employee of the core facility, but because he got his own grants, he does not have enough capacity to work or to be employed in core facility, but still he's enthusiastic enough. He comes and help us, especially some complicated protein work is his domain. No one else will be able to do it. All our equipment can work in user or service mode. In general, if you use NMR regularly, then it makes sense to learn how to do it, and you can measure independently. If you are just an occasional user, then we can do the measurement for you. The training is mainly through the course, which is listed in information system as practical NMR spectroscopy of biomolecules. So it is a regular course for students, but everybody is welcome. So even if you are not a student anymore, or people from outside can also come. The course is running every semester and extend is about 25 hours. So because NMR is quite a complicated machine, so the extent is it's like going to a driving school. The spectrometers, or essentially the equipment, is booked through SATEC reservation system, which is accessible on this address. And of course, NMR is an expensive method, so you do not want to pay full cost of the measurement. So there is financial support available for academic users. So for the Czech users, it is especially this Czech infrastructure for integrated structure biology, and then for international users, INEX Discovery and Instruct. We have also a monitoring system because the experiments are long. And of course, the user does not sit 3 weeks at the spectrometer watching the data is being collected. But if you are running a long experiment, you should at least from time to time check that the spectrometer is not waiting and asking you whether it can, for example, overwrite the old data. Then we have the data policy, which essentially says that you should observe the rules that are common for Masaryk University, that everyone shall work under day one login, so that we know who is using and we can contact the person quickly in case something goes wrong. And that, of course, we are a spectroscopic facility and not a data storage facility. So you cannot leave all your measured data at spectrometers permanently. We do not delete intentionally anyone's data, but there are quotas. So at some point you would run into the quota and would not be able to collect the data anymore. No. Okay, survey of user satisfaction. It is interesting actually, because normally you would expect that there would be some kind of Gaussian distribution, that people would be moderately happy and with few people on the extremes. Actually, the pattern is just the opposite. Most users grade our facility excellent or very good. Then there is a very little middle ground, and there is a small but persistent part of users who are totally unsatisfied with everything. The core facility is difficult or impossible to get in. If you do get in, nothing works, and the staff is lazy and incompetent. I checked, we are not alone with this. Actually, most core facilities see this pattern, except from the proteomics. And in the proteomics, they do not let the users in, and they do all the work themselves. So that may be the key, that if you do all the work for the users, then they are happy. Then there were some comments about insufficient IT support. We want to address this question that we are organizing a workshop on data handling in the core facility. It is next week. So we have something like 4 slots still available. So if you are interested, let us know, and you can come and first listen to the presentation and then ask question how to transfer the data in, out, and so on. Okay, so as mentioned, we are financed mainly by Czech infrastructure for structural biology, and it requires that every publication that uses the data obtained in our facility give the acknowledgement. So this is the wording of the acknowledgement. Please pay attention to that, because of course the future financial support depends on how many these acknowledgements we get. There are publications, of course, these are publications that gave us the credit. They are not all of them. They are more every year is about 10 to 12 publications. Like that. I just chose a few, let's say, high-profile journals that show how smart and hardworking our users are. So that's all, and I thank you for your attention with this quite dated picture. Petra Papushkova as a student here, Karen Kubicek as a young promising scientist.
Okay, so we have first question in the chat. Yeah. So what are some of the most common use cases of NMR in practice? I suppose it's in medicine. It's from Václav Tesař.
I think I mentioned it here, though I did not talk about that. So, okay, very originally, NMR was used, especially in the organic chemistry, that the chemist performs a reaction and needs to check whether he got or she got those types. There were not that many women in science. Whether they got what they are aiming for. Okay, so that's the very original use of NMR. Today, the use is very broad, from compound identification, that was just this case. In industry, the quality control, for example, in pharmaceutical industry, there are strict requirements about they have to check how pure or even whether the sometimes only one of the isomers is certified as the drug, as the medical compound. So you can do it as well. And higher level is complete structure determination. That means that you find out how these atoms are connected together, and in the flexible molecules, now we are getting to the realm of proteins, for example, that can fold in different shapes. So eventually you can get even three-dimensional structure. That means coordinates of all atoms in the molecule. Well, this is the task. Other methods can do it as well. For example, if you are able to crystallize your compound, then X-ray crystallography will give you the answer faster and more accurate. But if it does not crystallize, or sometimes it does crystallize, but it changes the structure during the crystallization, then NMR spectroscopy is a good method. And it's not only the structure, because you can measure in the natural environment of the molecules. Again, I am talking about the biomolecules, where in water they can move, and you can study interactions either with some small molecules like potential medications, or interactions of protein, or between protein and nucleic acids. So that's a strength of NMR, because actually there are not that many methods that can do this one. And also I would stress again that compare, let's say, to spectroscopy in ultraviolet or visible light, we are applying about 7 orders of magnitude less energy. So there is no danger that we break any bonds or introduce any reaction or change the configuration of the compound. So that's the use of NMR.
Yeah, and the follow-up question: were there any uses of NMR related to COVID research?
Oh yeah, there is not in our lab, but yes, there is actually the whole project, European project, like NMR applied to COVID studies, and I don't know exactly what were the outcomes, but yes, what I just said, it is good for the interaction. So you can study, for example, how this COVID binds to the membrane or whatever. So yes, it was of course done, and there was a specific project of the EU intended for this.
I have a question about the bioreactor for studying in living cells. I wonder what type of cells can be used in this system. Is it just the oocytes, or?
The system's HeLa cells. Well, originally it was possible only on frog oocytes, because they are big and people were introducing the compounds inside, which is like injecting. But they are not that relevant, so now there are methods to get the compounds into the mammalian cells, and either chemical or electrochemical. And this is, well, but the problem is, again, the sensitivity NMR is not the greatest. and you need to measure for quite a long period, and you don't want the cells to die. So you have to feed them throughout the measurement. So that's the purpose of this bioreactor, that essentially it keeps the cells alive.
Question about the diffusion probe.
Yes.
Can it be used for heterogeneous samples and give you some quantity about the distribution of the populations?
Populations, frankly, I don't know.
Oligomerization state.
Frankly, I don't know. Generally, if the sample is inhomogeneous, you know what's happening, right? That you get broad signals, and you cannot get get enough resolution to identify the compounds. But as I said, the probe is here, but was not installed yet, so we do not have any practical experience.
I guess a simple dose experiment, if you mean heterogeneity in terms of the oligomeric states.
I saw that there would be like, layer in the sample, with more density and with less density and so on. No, that's of course, that was of course what I was talking about, that you get broad lines and it will be hopeless. Yeah. So we will see how good the resolution will be eventually on this probe. The gradient is at least 10 times, but I think even more than 10 times greater than on normal probe. So the resolution should be really much better. Comment.
Yeah,
Oh, okay. You only clarified that I did not understand what Ilka was talking about.
Sorry for my English.